applications of derivatives to kinematics. Distance, speed, and time. So what is kinematics? The motion of objects. This is like physics. So now we're going to apply our calculus to give us understanding of physics. Because most of the time when students learn physics, you just get what? A bunch of formulas. Here are 8,000 formulas. Here's a question, good luck. Sometimes it feels that way, right? Just make sure you use the right formula. Well, what we're going to do in calculus right now is understand why some of those formulas work and be able to just do them through an understanding perspective rather than by just using formulas. And we'll start off really straightforward. So, you have velocity. Common rate of change connects velocity, displacement, and time. So the rate of change of displacement with respect to time is called velocity. Right? How fast are you driving? I'm going 100 kilometers per hour. That would be considered a speed because I don't tell you a direction. If I was saying, I'm going 100 kilometers per hour this way, now I have a velocity because I have a direction along with my speed. And rate of change, displacement, measured in, like for cars we usually do kilometers, time we measure in hours, then we have kilometers per hour, right? It'd be very confusing if they started changing your speedometer. Oh, I bought a car that's, my speedometer is kilometers per second. And I'm very confused. Because it's very small numbers. You're not going very many. If the maximum on there was 1 kilometer per second, that would be super scary for the speed of that car. Okay? The average velocity, we've done averages a lot. That's just the slope of your secant line. Which is, how far did you go? How long did it take you? Oh my goodness. I have a very bad YouTube video I'll show you later. If we have time. I think we'll make time. I'll speed up so we have time to watch said video. But yeah, average speed. Kilometers per hour. You take 2 hours to travel 100 kilometers. What was your average speed? 50 kilometers per hour. Awesome. Oh, I can't wait to show you that video. That was a good memory that just came to my head. Instantaneous velocity is your first derivative of displacement. So if you were able to graph a distance versus time graph, and you had an equation, if you find the derivative of that equation, that's your rate of change, instantaneous rate of change of displacement over time. That's just velocity. And of course, if you take away direction, that's just your speed, which is the absolute value of velocity. Because sometimes velocity has a negative, like the same thing with acceleration. What's gravity? Negative 9.8. And when someone's complaining, why not just use 9.8 positive? Well, that would be a very different world we'd live in, where we wouldn't live there very long. As we'd fly, everything would just sort of like, if you weren't attached to the ground, whole world would be like helium balloons. Okay, displacement of a body at time t seconds is given by this equation. Find the average velocity. So average velocity is just change in distance. There's my two distances over change in time. So my distance changed from 4 to 18. My time changed from 1 to 3. 7 meters per second is the average velocity. So the important thing for kinematics is to learn that if you have displacement, its derivative is velocity. We're also going to learn that the derivative of velocity is acceleration. I don't know who came up with S for displacement. Displacement, maybe, I'm not sure. You'd think D, but no, S for displacement, V for velocity, and A for acceleration. So the derivative of displacement is velocity. The derivative of velocity, acceleration. I just remember as a word. And then that's, okay. One derivative is the next going forward. Okay? So if you want to find the velocity, you take your displacement formula, you find its derivative, which is just 2t plus 3. This is an equation for all of the instantaneous velocities. Do you ever have the word initial in physics? What does it mean? The starting point. What do you know at the starting point? 0 for t. So we just plug in t is 0. The initial velocity is 3 meters per second. So if you wanted to find the velocity after 4 seconds, you have your velocity formula. You could just plug in 4 and get 11 meters per second. Okay, so I have a plan so that we can watch this video. My plan was to give you time to try this question on your own. We'll do that, but maybe we'll do that at the very end. So if we have lots of time, then we can, I don't think the video is very long if I find it. So I'm going to leave this, we can go over it maybe beginning of tomorrow's class, or even we might have time at the end of class. So I'm leaving you example 2 to do together. Acceleration, right? The rate of change of velocity with respect to time is called acceleration. So we've got, to help us remember all of this. And so we can write acceleration as the first derivative of velocity, which means that it's the second derivative of displacement. And if we would go back and look at your grade 11 textbook, and you know you had parabolas, and someone would take something and throw it up in the air, just like this last question, in fact. Let's look at this last question. This is like a grade 11 question. A stone is dropped from a cliff. Its height is given by this equation. So you could have graphed this and found its vertex, blah, blah, blah. I just want to point out that its first derivative here is negative 9.8t. And its second derivative is constant, negative 9.8. So if you would go back to your grade 11 textbook questions, you'll almost always see in calculator questions they use negative 4.9. When it was non-calculator, they rounded up to 5 so you could factor. And if they wanted to use American, they'd use 16. Because 16 times 2 is 32, and that's 32 feet per second squared is gravity in feet per second squared, so you could be more American and not have to use nice number systems. Okay. So the instantaneous acceleration is the first derivative of velocity or the second derivative of displacement. So when you're thinking about this is one derivative down, or you can go 2 derivatives down to go directly from S to A. And we'll do a question involving acceleration here. The displacement S meters of a particle at time t is given by this equation. Find the velocity after 1 second. So we find our velocity equation by just taking the derivative. We could plug in 1, not hard. You might even skip writing those numbers down and just write the answer, because I'm pretty sure you could plug in 1 and figure it out. What does it mean if a particle is at rest? It's having a nap? It's not moving. Okay? And if it's not moving, its velocity is 0. Whenever you have gravity involved, like if I throw this golf ball up in the air, there is a moment, instantaneous moment, where it changes from going up to coming down. At that moment, we say it's at rest. And a little nap there, very short nap, instantaneous nap. And then it comes back down, because its velocity is 0 at that point. Oops, that was. So, velocity 0. You could take your velocity equation, plug in 0. And a lot of the kinematics questions is just, I can use my derivative to go from one equation to the other. Just, am I using the right equation? So I have to know when a particle's at rest, its velocity is 0. What is its acceleration after 1 second? Again, I could plug that in. To my acceleration, which is just the derivative of velocity. So I have my velocity equation. I took the derivative again. Now I could plug in 1. Make sure our units are correct. So velocity is meters per second. Acceleration is meters per second squared. Does physics like to do this, Lux? No? Yes? Some places? Some places you'll see that notation more. I like the slash and the per second squared. It makes, like, how would you read this? Meters, seconds, negative squared? I don't know. It just doesn't roll off the tongue that way. But you'll see that at places as well. At what time is the acceleration 0? So we plug in 0 for acceleration and solve, and it's at 4 seconds. So on page 42, you have a second acceleration question. I will leave that for you.